Hi, this video is lesson 2.2, part A, starting on page 57 of your workbook. First thing to do here is so last unit we saw that you couldn't just add the radicands, that didn't work. But we do need to be able to add and subtract radicals, so we're going to work on that this lesson. So take your calculator and figure out which of these radical statements are true and circle the ones that are true and place a single line through the ones that are false. This is really important to do because part of this is practicing working with your calculator and being able to get these correctly with your calculator. Okay, so pause the video, go do that, and come back. All right, you should have found that these three are all correct. And these ones over here are wrong. Now, can you suggest a rule for adding and subtracting radicals? Pause and think about that for a minute. The rule is that you can add and subtract identical radicals. So that means that the index and the radicand are the same. So the radical part of the expression has to be exactly the same. So let's do some examples of this. So if I look at example 3, this is root 7, this is root 7, this is root 7. And I sometimes talk about bags of apples because I've got 8 bags of apples here, and I'm taking away 3 bags of apples, and then I'm adding 15 bags of apples, because it doesn't really matter what it is I'm adding or subtracting, but they're all the same thing, okay? So 8 minus 3 is 5 plus 15, so this becomes 20 bags of apples, or actually 20 root 7, which is the actual answer there, okay? If you do this one, these are all the same, the radicals are all the same, so 18 plus 20 is 30, minus 7, this is 23, times the 5th root of 10. And this is root x, and that's root x, so 5 root x's. And if I take away 4 root x's, I have 1 root x left, and I just put that as root x. I don't need the 1 as the coefficient. Okay? So next step is use your calculator to verify that this is true. And then what do you think about question B? Go ahead, pause the video, check these calculations. Hopefully you saw that this is correct and this is correct. And does this appear to contradict the rule that you wrote above? Yeah, it appears to, because we definitely did not have like radicands there, or like radicals. We didn't, but we can make them like radicals. So let's take a closer look at this. So I've got 2 plus root 8. Well, I can rewrite root 8 as 2 root 2. So if I've got 1 root 2 plus 2 root 2, that is then 3 root 2's, which is what we got up here. Yay! This is, so a shortcut, now that you've hopefully gotten quite comfortable with converting these to mixed radicals, one shortcut that people often use is they have this 12 and you write that as, that's 4 times 3. Oh, the computer does not like 4s. 4 times 3. So then this is going to be 5 times, 4 is my perfect square, so the square root of 4 is 2, and I can't do anything with the 3, so that stays as root 3. And then the 6, my perfect square in here, this is 16 times 3, so this becomes 6 times the square root of 16, which is 4, times root 3. So then I have 10 root 3 plus 24 root 3. And if I add those together, I can do that now because they're like terms, and this is 34 root 3. Okay, next page. So the rule is, in order to add and subtract radicals, they must be able to be expressed as like radicals. That's the term that we use, like radicals. Just like terms, right? In algebra, you collect like terms. So we're going to rewrite these so that they're can do that as a single radical. So 80, that is going to be 16 times 5, so that's root 4 root 5, oh, sorry, 4 root 5, not root 4. That is the danger of doing it this way, if you shortcut it, because I need to take the square root of 16, which is 4. Minus, and 20 is 4 times 5, so this is 2 root 5. So 4 minus 2 is 2 root 5. This one, I need the cube root, so I'm going to just write it out in a little bit more detail here. So I'm going to write this as the cube root of 8 times the cube root of 10 plus, and then this I can see is going to be 27 times 10. So that's the cube root of 27 times the cube root of 10. Now I'm doing some of the shortcuts here. If you don't see the shortcut to find the cube root or what you can take out of it, remember you can always do the prime factorization because that will get it for you if you don't immediately see what the biggest perfect cube or perfect square that you can pull out is. Okay, so cube root of 8 is 2. I can't do anything with cube root of 10. And the cube root of 27 is 3, cube root of 10. So this equals 5 times the cube root of 10. Okay. And the last one here, this is going to be 27 is 9 times 3. So this is 7 times 3 root 3. 75 is 25 times 3. So that's minus 3 times 5 root 3. And then 147. Well, if I'm doing this question, I'm figuring that's probably going to be something times 3. So if I take 147 divided by 3, because I'm assuming I'm going to have the same radicand left over, I get 49 root 3. So this is 49 times 3. So that's 2 times 7 root 3. So I got 21 root 3 minus 15 root 3 plus 14 root 3. And then 21 minus 15 plus 14 is going to be the same as 21 minus 1, which is going to be 20 root 3. There's my answer. All right. Now, this next example is, this one, it told you that you were going to do it into a single radical. This one might not necessarily do that because I'm just simplifying it by combining radicals. So don't be surprised if they don't all come to the same radical, but some of them should be the same. So I'm not going to do this shortcut up here because I made mistakes doing that. So I'm going to do it. I'm just going to put the result down because I don't need to spend time doing that. You should be able to do that already by now. So this is going to be 5 times 6 root 3 plus 3 over 4 times 2 root 2 minus 5 over 4 times 4 root 3 plus 1/2 times 5 root 2. Okay, I can do some simplifying. These 4s just cancel out, and this 2 becomes a 2 on the bottom and a 1 in the numerator. And technically, I should have 1s there, but I usually don't bother with them because I'm lazy. Okay, then I have minus 30 root 3 plus 3 root 2 minus 5 root 3 plus 5 over, oh sorry, this was 3 over 2, and 5 over 2 root 2. And then I can go minus 30. So I've got my root 3 terms are the same. So I've got minus 30 root 3 minus 5 root 3 is minus 35 root 3. And then I've got these other like terms here. But I've got fractions, and those are ugly, so I'm actually going to go over to the side and do my fraction calculations. So I've got 3 over 2 bags of apples plus 5 over 2 bags of apples. That's 8 over 4, that's 8 over 2. Okay, maybe recording the videos late is not a good idea. Okay, so that equals 4. So that's what my coefficient is going to be there. So this is going to be plus 4 root 2. And I'm just going to underline that in red so that you see that that came from here. This is the way I maintain the flow of my work by like the work goes down the page. This line equals this line equals this line. But if I needed to do that fraction addition, especially if they had different denominators, it would just make a mess in here. So I just take that little piece of it over to the side and do that calculation and then bring the information back here. Okay. Okay, and then example B, this one is really pretty ugly. So again, I'm going to sort of rush through the simplification of them because that's something like converting them to mixed radicals in simplest form is something that you should be comfortable doing now. So I get 4 over 8 plus 10 times the cube root of 3 minus 2 times the cube root of 2 minus 5 times the cube root of 3. And now I can simplify that because I've got 2 terms with the cube root of 3. So this reduces to 1/2 plus 10 times the cube root of 3 minus 5 of that is 5 times the cube root of 3 minus 2 times the cube root of 2. And then if you're allowed to use a calculator that does cube roots, which you're not on the test, you can then check this in your calculator to make sure that it is the correct answer. Okay? All right, that is the end of the first part of the lesson. Go do some practice and then come back and we'll do some, we've got one more example to do.